Welcome random viewer. Today, we're using one of the fanciest words in chemistry, spectrophotometry, to do what humans have done since the dawn of time. Stare at colors and overthink them. Except with science, spectrophotometry basically measures how much light a solution absorbs. In other words, we're shining light through something and asking, hey, how much of that did you eat? It's kind of like how your sunglasses block light, except instead of looking cool, we're just calculating wavelengths and pretending we understand quantum mechanics. Each compound absorbs light differently depending on its concentration. That's where the Beer-Lambert law comes in. Absorbance is equal to molar absorptivity multiplied by path length multiplied by concentration. Absorbance is how much light the sample eats. Epletion is molar absorptivity, how good the compound is at absorbing light. L is path length, usually 1 centimeter, which is the distance light travels through the cuvette. C is the concentration of the sample. Keep this in mind. More concentration, more absorbance. Now during the experiment, we scan across all wavelengths, not because we're bored, but to find something called lambda max. That's the wavelength where absorbance is highest. It's like your sample's favorite color of light to eat. You'd scan across all wavelengths when you don't know lambda max or when you want to compare compounds to see which absorbs more strongly. So scanning gives us qualitative data, what colors are absorbed, while measuring absorbance at lambda max gives us quantitative data, or actual numbers we can plot. Now for the experiment. For our experiment, we had 3 different solutions, 1 blank solutions and 2 experimental solutions. We transferred these solutions to cuvettes to be used in the spectrophotometer. When transferring your solution to the cuvette, don't pour neither too much, nor too little, make it just right, like Goldilocks, but with acid. If you have either too little experimental solution or some is still left in the beaker, wash or fill the remaining with the blank solution. For our case, water. Now we zero the spectrophotometer with distilled water. The machine must start with nothing before it measures something. First wipe the cuvette on both sides, no fingerprints allowed. Science says no smudges. Place it with the clean sides facing the light beam, close the lid, and on the computer select the zero option in the top left. As a reminder, if you forget to zero the machine with a blank sample, congratulations, you just made up data. The absorbance will be way off. Yay, you zeroed correctly. Have a cookie. Now, we do the exact same process for our 2 samples, cleaning, placing and closing, but instead of zeroing the machine, we press the start button in the top middle. This graphs a wavelength and absorbance curve, the absorbance values of which we will record and use to graph our calibration, Beer's law curve. Remember to close the lid and clean up the air when you're done. Remember to dispose of the liquids properly and clean up your workspace and utensils.